Hello there! This series is all about differential calculus. I understand that learning this math subject needs a hard work for some. That is why I will make my discussions as simple as possible. The handout or note for each topic is provided through a link under the description below. However, the solution manual for each exercise and some important notes are not included. It's your job to fill in the gaps by watching the whole video, and of course, don't forget to take some notes. So let's start our first lesson. Our first lesson is all about functions. What is a function? Function is used to describe the relationship between terms, wherein these terms are also known as variables. They are called variables because their own values vary or change. To understand further, we will go to this setup. This is the common way to explain functions. An input goes to this box. Others can imagine this as a machine. This machine will process this input, yielding to an output. We are going to relate this to functions. We have our first term represented by the variable x. This will be our input. Then, this machine will do something to this input, or in math, it will process the relationship. This relationship could be a formula or equation or any other type. Then, it will lead to another variable called y, which will be our output. For example, the value of x is 1. The machine will process it, leading to the value of y as, for example, 3. Then, we change the value for x. For instance, it is now 2. Then, the value of y is changed as well. For example, it becomes 10. For every value of x, if you are going to observe, there will be a corresponding value for y. So this setup explains what function is. It will describe the relationship of these two terms or variables, which are x and y, as they change their values. But take note that more than two terms could be involved in functions as well. If you look at this setup, y is dependent on x. Thus, it can be described as y is a function of x. We will go to these examples to show you that functions are widely used. For example number 1, y is equal to x raised to 2 plus x plus 1. If we are going to assign a value for x, like 1, all we have to do is substitute 1 for x. Therefore, it will become y is equal to 1 raised to 2 plus 1 plus 1. And if we are going to solve this, y will be 3. Next, we are going to assign another value for x, which will be 2. Solving this, leading to a value of y, 7. And finally, let's try to assign another value for x, which will be 3. It will become y is equal to 3 raised to 2 plus 3 plus 1. Solving this, we'll have a value of y, 13. If you look at this, this is an application for function because for every value of x, there is a corresponding value for y. We can conclude that y is a function of x for this example because y is dependent on x. For example number 2, this is the volume of the cube. We represent the length of the edge as s. And we already know that the edges are all equal. For instance, we will find for the volume. The equation, if you recall, is the length of the edge raised to 3. On this example, volume is equal to s raised to 3. If we are going to plug in any number to s, there will be a corresponding value for volume. Therefore, the volume of the cube is a function of the length of its edge. For example number 3, we will determine the area of the triangle. We represent this as our base, or small letter b, and this line or dimension as height, or small letter h. We already know that area is equal to 1/2 times base times height. Once again, we can assign any values for the base and the height, and the value of the area is affected as well. Therefore, the area of the triangle is a function of its base and height. If you look at this, there are 3 terms involved: the area, the base, and the height. Thus, we must not limit ourselves with just 2 terms when we talk about functions. The next part is all about the notation of a function. When we say notation, it refers to symbols that represent something. For function, the common notation is a letter F and an X with an open and close parenthesis. For example, let's write this one. Y is equal to this notation wherein the equation involved is x plus 1. Take note that the parenthesis here does not indicate multiplication. Instead, it is read as a function of x or f of x, wherein f indicates the name of the function and our x here will be our independent variable, or it will become our input value. This one will provide the relationship to provide the output. And this one indicates that y is a function of x. However, let's not limit ourselves with letters f and then x. Other letters may be used as well. Examples are already provided here. For example number 1, look at this. G of x is equal to x raised to 2 plus x plus 1. So the input variable or the independent variable will be still x. And then the representation of this particular function or the name of this particular function is g. Another example could be this one as well. H of b is equal to b raised to 2 plus b plus 1. The independent variable will be letter b, and the name of the function will be letter h. Capital letters can be used as well, like this following example. So for this example, our independent variable is t. Meanwhile, the name of the function is capital letter S. Let us again observe this another example. A of r is equal to pi r raised to 2. If you look at this, this is an equation for finding the area of a circle wherein this r refers to the radius of a circle. Okay, so the name of this function is letter A, pertaining to the area. And it is a function of the radius. Take note that this symbol is already constant, which pertains to pi, and you already know the value of pi. Functions have wide area of applications, so it is convenient to classify them. There are many types of functions, but in this video, we will learn just 9. The first type is linear function. This is regarded as the most simple of all types of function. It is in the form y is equal to mx plus b, wherein m and b are constants. It is called linear because it forms a straight line when we are going to use a graph. For example, this is our y-axis and this is our x-axis. Linear functions form a straight line. So this will be our y is equal to mx plus b. And m refers to our slope and b is our y-intercept. The second type is polynomial function. From its name, poly means many and nomial means terms. Therefore, polynomial means many terms. A term can be a number like 8, 4, or -2. It can be 4x raised to 2, a number and a variable with exponent, 3a, a number and a variable, 6b raised to 3, or h only, just variable. These terms are separated by addition and subtraction. For example, x raised to 2 plus x minus 1. There will be 1, 2, 3 terms. So there are just 3 terms for this example. Another example, 2x raised to 4 minus 7x squared. There are 1, 2 terms. And last example, I will just write it here. 4x raised to 5 minus 8x raised to 3 plus 10x plus 6. There are already 1, 2, 3, 4 terms. For example, y is equal to 2x raised to 4 minus 7x raised to 2. We can assign any value for x, and y is a function of x. The third type is quadratic function. It is in the form ax raised to 2 plus bx plus c, wherein a, b, and c are already constants, and of course, a should not be equal to 0. If this will be 0, this will be cancelled, leaving behind a linear function only. I know some of you are wondering that this is already under polynomial function. However, I tried to separate this because it has many applications. They can be used to describe moving objects that form parabolic paths like projectile motion, like this one. The fourth type is rational function. This type refers to the ratio of two polynomials. It is in the form f of x is equal to p of x divided by q of x. These two polynomials are based on variable x. An example is x raised to 2 plus 1 divided by another polynomial 3x raised to 2 minus 2x plus 2. However, there is a condition for this type of function. If we are going to assign any value for x, this q of x should not be equal to 0. If it will be equal to 0, for instance, 4 over 0, this will not be a real number. For the next two types, I will discuss them at the same time. These are power functions and exponential functions. For power functions, they are in the form f of x is equal to ax raised to b. Meanwhile, for exponential functions, f of x is equal to ab raised to x. These a and b are already constants. We can already plug in any value for variable x. The difference is just the placement of variable x. For power functions, x is the base. Meanwhile, for exponential functions, this x is the exponent. Another type is logarithmic function. This is the inverse of exponential function. For exponential function, it is in the form y is equal to ab raised to x. For example, let's just say a is equal to 1. If we simplify this, it will be y is equal to b raised to x. If we are going to express this in a form of a logarithmic function, it will be x is equal to logarithm or log base b of y. To understand, let's have this example. 1,000 is equal to 10 raised to 3. If we try to expand this one, it will be 10 times 10 times 10. It just shows the number of times this 10 will be multiplied to arrive 1,000, which is shown with this exponent 3. In a form of logarithmic function, it will be 3 is equal to logarithm base 10 of 1,000. This type of function shows the number of times this base 10 is multiplied to arrive or to bring out a number of 1,000. And the answer is 3. Before I forget, this function could be read as the logarithm base 10 of 1,000 is 3. Trigonometric functions are included as well. They can be in the form of f of x is equal to sine of x, cosine of x, and tangent of x. And let's not forget their inverse counterparts, which are cosecant of x, secant of x, and finally, cotangent of x. These functions provide the relationship between the angle and even the sides of a particular right triangle. The last type is called sinusoidal function. It is in the form y is equal to a sine of bx plus c. A, b, and c are already constant. If you look at this is an example of a trigonometric function, but I tried to separate this once again like quadratic function because it has a wide scope of applications, like describing anything with the shape of a wave. So this concludes these 9 types of function, but there are more other types of function, and it's your job to find them out or to research them if you are curious of them. Functions can be expressed through a curve or line drawn on a graph. So this is our example of a graph wherein this horizontal line can be considered as x-axis and the vertical line refers to our y-axis. Each type of function conveys a certain curve or line. One way to draw the curve is to plot the points. We just assign certain values of x, that is for the x-axis, and then we are going to determine y, that will be for our y-axis. Let's immediately go to example number 1. Y is equal to 2x plus 1. This is an example of a linear function. Therefore, we are going to expect a straight line. To test if it is really a straight line, we are going to assign some values for x. Let's start with -3. Then proceed to -2, -1, 0, +1, +2, and +3. Next thing to do is to compute for y. What we are going to do is substitute this value to the variable x. For example, for x is -3, so f of -3 is equal to 2 times -3 plus 1. That will be equal to -5. Therefore, if x is -3, y is equal to -5. Let's continue with -2. So for f of -2, which is equal to y, is equal to 2 times -2 plus 1. The answer is -3. So let's write down -3 for y. Okay, I will immediately write down this answer. Please do it on your own for the computation for y to test if these values that I am going to write are correct. So if x is -1, y is -1 as well. X is 0, y is +1. X is +1, y is +3. X is +2, y is +5. And finally, x is +3, y is +7. Then, we are going to plot these points to our graph. If x is -3, so this is our origin, 0 for x-axis and 0 for y-axis. So, x is -3. Let's move to the left. -1, -2, -3. Y is -5. So, let's go down. -1, 2, 3, for 5. So this is our first point. If x is negative 2, okay, this is negative 2, y is negative 3. Negative 1, negative 2, negative 3. If x is negative 1, y is negative 1. If x is 0, y is 1. To avoid some confusion, I'll just put some x mark here to disregard this as a point to our function. If x is positive 1, y is positive 3. X is 2, y is 5. And finally, x is 3, y is 7. Then let's try to connect the dots. I apologize if the line that I draw is not that straight, but it is really a straight line, and I will try to place some arrow signs at both ends to indicate that we can still add some values for x and we are able to determine more values for y. Therefore, this line can continue. So that will be your number 1 for graph of functions. For your example number 2, y is equal to x raised to 2 plus x plus 1. The same process, we just have to assign certain values for x, then we are going to determine y. So we are going to assign the same set of values from example number 1. I'm just going to add some numbers here later. Let's start with negative 3. And by the way, this is under x. Meanwhile, this column is for y. So let's continue. Negative 3, negative 2, negative 1. And then I will just try to add some number here. Negative 0.5, 0, positive 1, positive 2, and finally positive 3. Then we are going to determine the corresponding values for y. I am not going to provide the solution once again here because the solutions are quite easy and you can do these solutions on your own. So I will immediately write down the answers for y, but please take time to compute these values to check if these values to be written are correct. So if x is negative 3, y is positive 7. Okay, I will just write the answers. Positive 3, 1, 0.75, positive 1, positive 3, positive 7, and lastly, positive 13. Our data is complete. We just have to plot these points to this graph. So this bolded line is the origin for our x-axis. So this will be 0 for our x-axis. And of course, this vertical thicker line will be the origin of our y-axis. If x is negative 3, so let's start from this one. 0, 1, 2, 3, negative 3, y is positive 7. So let's just count 7 grids upward. 1, 2, 3, 4, 5, 6, 7. So this will be our point number 1. If x is negative 2, y is positive 3. So 1, 2, 3. If x is negative 1, y is positive 1. If x is negative 0.5, so the half of this grid, y is 0.75. Positive 0.75. If x is 0, y is 1. If x is 1, y is 3. If x is 2, y is 7. And lastly, if x is 3, y is 13. So I will just count 13 grids upward. 7, 8, 9, 10, 11, 12, 13. If you want your points to be more symmetrical, let's just add another value here for x, which is negative 4. And that will be equal to positive 13 as well. So this is our negative 4, and then move 13 grids upward. So this is positive 13. Then let's try to connect the dots. Okay. Okay. So this is our graph. Please bear with me with the drawing. If you want to have more accurate curve, just make the increment for the values of x smaller. For example, 0.5. That's why the sequence could be negative 4, negative 3.5, negative 3, negative 2.5, and so on. The main reason why I decided to add a value of x negative 5 to our data to determine or to show you that this point provides the lowest focal point of this parabola. Once again, let's end this with arrows to indicate that these lines can proceed or continue. So that will be your example number 2. And that's the end for the discussion part for functions. So thank you for watching this whole video. And don't forget to get your own handout. You can grab it through the link under the description below. Exercises will be provided through the next video and it will be uploaded soon. See you there.